So, in this video I'll show you how to perform the batch multi-subject cropping, which is an important step in the biodistribution analysis when you perform longitudinal scans with a multi-mouse bed. And your input is typically here a sequence of scans from a PET-CT or SPECT-CT. And then inside you have your CT and SPECT data, for example. They can also be in subfolders. And here we have 4 mice in each scan. So this is the CT, and I can load the SPECT here as overlay. And now you see a signal here in the bladder, but also in the tumor. There's a subcutaneous tumor here. And then for the whole segmentation and analysis, you typically want to split the data per mouse. And so the first step is this whole splitting process. And of course, you can use our interactive cropping tool like this and add all the metadata that is shown in a separate video. But we have a faster method. It involves a dialog here for multi-subject cropping, but then the best way to do it for multiple scans is here this method for the batch multi-subject cropping. And for that you need to create some files, basically a CSV file here per scan, which indicates the mouse name and time point, the injection dose here in millicurie, for example, the weight, the injection measurement time, and then the cropping information, like where the mice are and how big their cropping region is. And you can create such a file once, and then you can reuse it for the other scans. And I'll show you how to create this file. You can help the software by giving mouse names here, M1 for example. You see here it's the left mouse, so always check in 3D if you're on the left or the right. And then M2, M3, M4. Then you can give some hint about the sizes here, so called height, width, and in another view here, depth. And then we go into the dialog here, and the other dialog here, the multi-subject cropping, and you say markers. Oh, it didn't like the markers because I had to put them on the overlay, so let's put them in the underlay. And 2, and 3, and 4. So the markers will be placed on the layer that you selected here, and I had accidentally selected the overlay. So let's try again here, multi-subject cropping, and now we use the markers, and now we have here all the information. And now we can save this as a template. You can save it here as cropping. I'll just rename it to temp. Now this file is saved. Now we can close the software. And now you can work on your Excel file and enter the missing information, the injection dose, weight, injection time point, in like this format here. I've prepared that, so I can delete this file, and we have it in here. And now there's a certain convention here. You can indicate here with a backslash the mouse name. I call it mouse 1, but you can use anything. And then here, this is the name of the time point. So this is 3 hours after injection. Then you can basically copy this CSV file after you entered the injection information, and then you can reuse it for the later time points here. And then all you need to change is this part, because it should end up in a different folder And the remaining information can be reused because it's the same mice typically, unless you reordered them somehow, and they only got injected once, right, before the scanning. And when you have done that, there is another file here. It's called pipeline settings.ini. It's a simple text file, and in there you can indicate more information, like some things might be missing in the metadata of the SPECT. So it might miss the voxel unit. You can enter it here, the scan start time, and the isotope. These are often or should be stored in DICOMs, but sometimes they might be missing, or here we have Nifty, so Nifty doesn't support this metadata. Yeah, and you need to indicate where what is your CT and what is your SPECT, and this can also contain a relative path to your files. Like if you have DICOMs, they are often in a subfolder, and then for the DICOMs you can just indicate one of the DICOM files and it'll load the whole 3D image. Then you can indicate here a special correction transform to improve the co-registration, and there I have one here in a subfolder, and this can be created using our Fusion tool, and here the Fusion, but that's another topic, and it is typically, or should not be required if your scanner is well calibrated and co-registered. And then you can add more parameters, like you can downsample the underlay, for example, if you want it a bit coarser, or the overlay if it's like too much in a high resolution. And you can find more details in our white paper about this video. There we will list all these parameters, and then you can use it. And this you can also copy and paste to the subsequent folders, and then you might have to just adjust it for the scan time, for example, and maybe for the different files here. And now our software will use all this information, and I'll show you how this works. You can open the analytics, and then you go to nuclear multi-subject cropping batch. Then you indicate, you tell it the root folder where you have your multi-mouse scans. And you can tell it the name of your cropping CSV file here. And then you indicate an output folder. Let's make it in parallel here, call it sorted test. And then you can say whether you want the SUV files or %ID. We'll take both, and you can save it as different output formats. I'll just use our format GFF. And then you can, for example, make a dry run and say crop, and then you can check if everything is complete. Otherwise, it'll complain and give you an error message. And then you can fix the data, like the voxel unit might be missing. And then you can use the real run and say crop, and now it's processing the data, and it goes into our folder here. See, we have the 4 folders, and the data appears here. So for each mouse, we have now 4 time points here. And inside each folder, we have the underlay, the CT. We can load it. We have the overlay, which is just your original overlay, cropped and enriched with the metadata that you added in the pipeline settings.ini file. But we also have here the %ID file, and you can load them and adjust the windowing. And now you can use our batch mode, or the nested batch mode, to quickly inspect the time points of this mouse or the other mice. And then you can also use our AI tool for batch organ segmentation, for example, but that will be shown in a different video. So this is the kind of the processing to prepare the analysis per mouse. So just to replicate or to repeat, we have as input, we have our multi-mouse scans. Each one might have 4 mice or 3 mice or 2 mice or just 1 mouse. And you need the cropping CSV file for each scan and the pipeline settings. And then you process your data, and you have this nice structure with one folder per mouse with multiple time points, and then you can move on with the segmentation and quantification, and you have these nice maps here in %ID and in SUV, and this one is in becquerel per ml. Okay, I hope this helps. Thank you. Bye-bye.